So we will start within a few minutes. Okay, we will start today's session. So I think the skin is visible to you all. So first of all, I welcome all of you to this live interacting session. This is our 12th live interacting session, and this is the last topic for this course. And I am Neil Alaskar, a PhD scholar from IIT Bhubaneswar, and I am your TA for this course. So these courses, I hope that all of you have gone through the course that has been taught by Professor Shubhashish Datta, right? So in this live interacting session, I will elaborate this concept with some fundamental numerical questions that will help you to clarify if you have any doubt regarding this concept. Okay, so coming to this course details, so this is fluid mechanics. As you have almost completed these courses, so this is the interdisciplinary courses you have got to understand as you have studied the fluid flow, fluid static, the pressure, velocity, how to measure pressure, how to find out velocity and pressure drop, and even losses in a pipe, and many more things you have studied. So all these things, even Bernoulli's equation you have studied, Navier-Stokes equation, all these fundamental concept that you have studied will help you in your BTech project, if you are interested in doing some aerodynamic problem or any fluid based problem. So that will be quite essential. Even in real life you are talking about, you can implement those things. Say if you need say if you need the velocity of this much or mass flow rate of this much from a pipe, so so you need to control regulate this inlet. So in the inlet, accordingly, by changing this area you can control this mass flow rate, so that at the outlet you got the desired, right? So that concept can be used. This is because you have gone through these courses, and which is quite interesting. So I suggest all of you please go through these courses, and initially the fundamental in each and every chapter is quite essential, and try to understand and visualize the problem in your mind, and which will help you to better clarify this concept. Okay, so in the last week we have discussed about this boundary layer approximation, and this was a quite important concept, as how this boundary layer affects this flow, and all these things we have discussed, right? So in the coming to this today's classes, and before this, let me tell you one thing, that as the exam is approaching, please have a look into this numerical problem, because the numerical problem that has been taught in this in all the live interacting session will help you to answer this question in the exam, because the question that will come is based on this fundamental approach, and you can go through this approach and easily solve such types of problem. Okay. So in this week we will discuss about this introduction to this open channel. So in this open channel we will discuss some numerical problem also. So and that problem will definitely help you to understand this concept, right? So up to this, what we have studied flow inside a tube, flow between two parallel plate, and all these things. So inside a channel, but now it's an open channel. So what basically is an open channel? So an open channel basically is a natural or man-made waterway. So that means one of these, say the liquid, the free surface of the liquid is exposed to the atmosphere, say at atmospheric pressure. If you are talking about the river, you see that this free surface of the liquid is exposed to atmosphere. So certain, and the water is continuously flowing. To certain types of flow is known as open channel flow, and this open channel flow is very much important for the civil engineering student, right? So please follow this courses quite significant. Now, as I talk about this open channel flow, as it deals with a flow where one of its free surface is exposed to atmosphere. Now, if the fluid is flowing, how it is flowing? It is flowing basically under the force of gravity. Suppose in a river, if you are talking about a river is coming from the upstream to the downstream. So why this flow is there? Because of the gravity, the volume or the weight of the fluid is displacing toward the downstream, and thus this flow is there, right? So natural example of this open channel flow is the river, stream, and all these things. And artificial, if I talk about this artificial open channel flow, these are the man-made structure like irrigation channel, or you can say irrigation channels mean in a channel you store some water for agriculture purpose and all these things. Okay, so that is the thing. So if I have to compare among these two, just a minute. So if someone asks you to compare flow through a pipe, that is pipe flow, and open channel flow, how will you distinguish between these two flow? That is quite important. So in the pipe flow, so basically the liquid fills the pipe, right? If this is a pipe, the liquid is filling. Okay, and it is enclosed in the outside direction by a surface. So we can't say whether the liquid is exposed to, whether any free surface of the liquid is there or not, right? In open channel, it is not fully enclosed. Say if certain types of channel is there, so this is a channel, right? Say these types of channel is there. So here the water is flowing, but the upper surface of the water or the liquid, that is the free surface of the liquid, is exposed to the atmosphere, and it is not in contact with any solid surface like that. So that is the open channel flow. So the difference, if someone asks you in the exam or anywhere in the interview, you just explain like this. Now I am moving to this some numerical problem and this fundament. So what my approach will be that I will give you a numerical question, and I will give you 1 minute time, And I hope that you have gone through the lecture. So assuming this thing, I am providing you a question, and you people please try to answer. Maybe it may be wrong, it may be right, but at least attempt. And after that I will discuss this fundamental concept for you, and after that we will tell you what will be the correct answer, right? So that will be my approach. So let us start. So the first question is that the flow in an open channel is turbulent if the Reynolds number is. So here just remember one thing, it's about an open channel, not pipe flow. So please try to answer. That is quite different. An open channel and pipe flow is different. So that's why if you have studied this thing, please try to answer. I'm giving you 1 minute time. Any idea? So one answer, I have received one answer, which is option D. So others, okay. So I am giving you this concept for you. So say if I talk about the previous classes, in the previous classes about this pipe flow, right? Sorry, in network issue is there. Suddenly load shedding is there, so this Wi-Fi issue is there. Okay, so let us see. Now is the skin visible? So see, for this pipe flow, what we have studied Reynolds number. The definition of Reynolds number is inertial force by gravitation force, so viscous force. So what is this? The formula is rho v d by mu. That was the formula, right? In case of d someone there is L, that is different thing. So if it is a flow through a pipe, if it is laminar, then the Reynolds number should be less than 2000, right? And it is transitional when if the Reynolds number is between 2000 to 4000, right? That is for pipe flow, and turbulent if it is greater than 4000. Okay, that is for pipe flow. Now if I talk about this open channel flow, that is one of the surface of the liquid is exposed to this atmosphere, there this Reynolds number formula will be same, it will not differ, it is universally same. But the thing is that this laminar, for this laminar, in case of open channel, so this in case of laminar, this Reynolds number should be less than 500, and transitional for if the Reynolds number is between 500 to 2000. So this range, please you remember this range because that will help. And for turbulent, this Reynolds number should be greater than 2000. So in this case, as it's an open channel flow and it is talking about this turbulence, so this Reynolds number should be more than 2000. So option B will be the correct answer. Okay, you understand this concept? Why it is more than to the, because it is an open channel flow. But if it is in the question, if say that if the flow in a pipe is turbulent, if the Reynolds number is, then option D will be correct answer. So Ridbi, I hope that you understand your mistake. Okay, so it's good that you have attempt. So next question, we are moving to this next question. So in this question, so basically this sphere of diameter is given and viscosity is also given, having a terminal velocity is given. So what is the value of coefficient of drag on the falling sphere? So coefficient of drag you are asked to find, right? So to find the coefficient of drag, first you need to find the Reynolds number. So I am giving you this hand. So first find out this Reynolds number. So I am giving you one more minute. So this question in this live interacting session on this open channel flow is mainly the majority of this application is for this civil engineering student. So at least they should follow this quite precisely because that will help you in their future research work, even in interview. So 1 minute, one more minute I am giving. Please try. Okay, I hope that you do not have idea about this one. Okay, I'm solving this for you. So say, so in this question, the main thing is that the diameter, what is given in this question? First you write down this thing. So first this diameter is given. This diameter is 0.02 meter. Next this velocity is given, which is 0.02 meter per second, right? And kinematic viscosity. So kinematic we can represent it as nu, which is 10 stroke. But I have to convert it into SI unit. So 10 stroke means 10 into 10 to the power minus 4 meters square per second. So that means it is 10 to the power minus 3 meters square per second, right? So this is the three thing that is given. So now we have to check. So the value of this Reynolds number. What is Reynolds number? Reynolds number is means we know that this is rho v d by mu. So again this term, what is this? This means mu by rho. So ultimately I can write this as Vd by mu. So I can put this value here. So this is 0.02 into 0.02 by 10 to the power minus 3. So ultimately this is 4 10 to the 4 into 10 to the power minus 4 into, that means 0.4 will be the Reynolds number. So see, as it's a open, sorry, as this Reynolds number is less than 1, so these types of flow is known as creeping flow or Stokes flow, right? So what has been asked to find out the coefficient of drag. So in case of that, the formula is 24 by Reynolds number. So certain value, say if the Reynolds number is greater than 1 up to a certain, there are certain formula of CD. So but the concept will be same. First you need to find the Reynolds number and check in which range it is, and corresponding there are certain formulas. The CD, that is CD equal to 24 by RE, or CD equal to this much by RE to the power something like that. There are certain formulas. So place in this formula you will get this CD value. So which is 24 by 0.4, that means 6 or 60. So 60, the answer we'll get is 60. Okay. So option B is the correct answer. I hope this you understand this concept. Okay, moving to this next question. So what is given in this question? The depth of the water below the spillway and after the hydraulic jump are 1 meter and 6 meter respectively. So you are asked to find the head loss. Okay, actually this is also a formula based question. So just I'm giving you this formula, and so the derivation is not required right now. So the formula for head loss due to hydraulic jump. So HL, hydraulic is represented by HL, which is Y2 minus Y1 cube by 4 Y1 Y2. So what is Y1 and Y2? So that Y2 means after hydraulic jump. and y1 is before hydraulic jump. So please place in this formula and tell me which will be the answer. So please put and tell. Yes. So I have got the answer. Two answer I have got. Same answer option D 5.2 hour. Yes, is the correct answer. So the correct answer is uh, 5.21 meter. So so I hope that you understand this thing, right? Any confusion up to this? Just tell me. So whether you know what is hydraulic jump and do you have any idea? Okay, I'm showing you what is basically this hydraulic jump is. Say hydraulic jump basically here I am throwing an example for you. Say a water body is there. So this is fully an water body. So a gate is there. So below there is path for the water to flow. Okay. This black one is the gate. So this is liquid. So as because there is certain head means certain height of the liquid is there. So once the liquid is flowing here, it will flow very rapidly. So what will happen? It will flow like this and up to a certain weight, and after that it will move like this. Okay. So there is a say this is a line. This is so this line I represent by red one. This is a standard line. Okay. So as this as the water because of this small area and by the continuing question, so there will be certain velocity, and because of this there is a rise. This rise is known as your hydraulic jump. This rise. Okay. As in this region where this is less than this line, so that is your supercritical. So this region is known as supercritical, and this one is your subcritical. Okay, so that is the thing. So I am moving to this next question. So actually, load shedding is still going on here. I don't know how much time I will continue this class. So let's see. So this is another question. So please try to answer this one. Okay, it's good that internet has come. So please try to answer this one. So what is given in case of an open channel flow, the frictional force is balanced by what? So just check why there is frictional force and all this thing. You just have to check this thing. Another thing is that it's an open channel uniform flow. So that is another important thing. So this is a fun. This is if you do not know any idea about this flow, that is okay. But the frictional force in class 12 you studied about this friction. So where does friction work? So the friction work against the motion. So in case of open channel uniform flow, why there is motion? Because of which term? Either pressure force or gravitational force or momentum force. So that thing you please look. So please try. So I have got one answer, option B. So let us check this one. So see in a uniform flow, as in this question, uniform flow is there. Uniform flow means velocity remain constant, right? So that implies no acceleration. So that is the fundamental thing. So in a river, say this is the flow. So if the liquid is flowing in this direction, okay, so there is a friction along with this surface. So this is my friction force. Say F represents this friction force. So something should be there that will oppose this friction force. What it will oppose? What will oppose it? So see, because of this water, there is a certain weight, right? Because of this weight of this liquid, and this is an angle theta, certain angle, so there is a component that will work here, right? So that force is my gravitational force. So what it will balance? It will basically balance by this gravitational force. So the frictional force is mainly balanced by this gravitational force when the fluid is moving from this upward stream to this downward stream, though this condition is not given here. Okay, so that is the so I am moving to this next question. So another this question can becomes like the which forces opposes this flow in an open channel. So in that case, you just say this is frictional forces oppose, right? So and this gravitational component of this weight will help the fluid to move downstream. So this is the next question. So please try to answer. Sorry for this issue. Any idea? So the lift and friction. Vidisha says the option C. So let's see. Okay, just a minute. The current has just come. Huh. So still checking all this thing. Just let's wait 1 minute for this connectivity issue. Hmm. Okay, let us check. So what is say the what is the effect? What are the effect on the body with mass immersed in a fluid which is under motion? So say a fluid is there, a moving fluid is there. In this moving fluid, you just immersed a body, right? This is a body that you have immersed in this fluid. So so two main types of forces will act here. So mainly what is the because say this is the fluid and this blue line represent the velocity of the fluid. So fluid has certain velocity, say this is the velocity of the fluid. Because let us assume that all the particles of the fluid are moving at a certain velocity and this mass of this body, extra body has a velocity u. So there is a difference in this relative velocity and this relative velocity. Because of this change in the velocity, there is a force from this momentum equation. Why there is a force? Because of the change in the momentum. So in this solid particle having velocity small u, whereas this fluid has velocity v. So there is a change in velocity, right? Right. So because of this change in velocity, so drag force. Now this what is drag force? So drag force basically acts along the direction of the flow. So it is the direction of the flow. So what it will do? It will oppose the relative velocity. So what is relative velocity? Say this v minus u. So see relative velocity concept. If I talk about this relative velocity concept, for this relative velocity, so if I asked you find this velocity of this solid with respect to this liquid. So this liquid already has a velocity v. So first what you need to do, you need to assume this velocity of this liquid as 0. So in the opposite direction I apply a velocity v. So this v minus v should be 0. As I have applied a velocity v, so here also the same thing should be applied, right? So in another cases, this is a solid which is having velocity u minus v or v minus u, right? So I just write u minus v. Consider u is more than v. General case, no, sorry. I write v minus u. I am considering that v is greater than u. Okay. So what will it be direction? So it will be the direction. That means if the fluid is kept stationary, it will appear that the ball is moving in that direction, relative velocity, right? All because see, I can we can also assume the same thing like it is this v is much more compared to u. So if this is a car and this is car number 2, so after a few minutes it will observe that this car 1 will move further distance compared to this one. So this car will observe that this car 2 is moving backward. So that is the concept here. Okay. So this drag force act in the direction of the flow, okay, and it always opposes the relative motion. So as the relative motion is in the backward direction, so this drag force Fd will act in the direction of the flow. This is drag force, okay. And why it is caused? It is mainly caused by the pressure difference and the viscous shear. Velocity difference you can also say, or the pressure difference. Both thing you can say. Pressure difference in terms of fluid, generally we represent it as pressure difference. So see, pressure and velocity are interlinked by this Bernoulli's equation, right? So this pressure difference and viscous shear. So the drag force is basically caused by these two things. So and another force will act. So another force that will act here is in the upward direction. That is the lift force. Say I represent it LF. So it is always perpendicular to this. It is always perpendicular to the direction of the flow. So why? Say see that concept lift force. If I talk about an aeroplane, right? So why an aeroplane will move upward? Because of the pressure difference, right? As the air is flowing, it will exert some pressure on this wing, and here there is less pressure. So what will happen? It will move it upward. So that is that concept. That is the air is always flowing in this direction, right? So because of this air, this bottom side will experience certain pressure which is more than this one, and this will uplift this flight. So that's why this lift force always act perpendicular to the direction of the flow. Okay. So in a fluid, so as this fluid means air is also a fluid. So if I talk about an aeroplane and an aeroplane is flowing inside a fluid, so what is this effect? So it will experience two main force. One is lift and drag force. Okay. So in case of fluid that is under action, generally we talk about lift and drag. So friction force we are not talking about, talking in case of this fluid, but in solid, only solid. If there is nothing mentioned about this fluid, in that case you can talk about this friction. So partially this you are correct. Okay. Now I am moving to this next question. I hope that you understand this. So it is asking you about this critical depth. Sorry, it is asking you about various types of depth. So please try to answer this one. Any idea? Okay, I am explaining this thing for you. I hope that you haven't studied about this thing till now. So before this depth, I am just drawing this above diagram, previous diagram. You remember this diagram? So this is a gate. This blue one is a gate, right? This red one is a line. This is standard line. The above one is a critical and below one is a subcritical, supercritical. So this one is if the above line I represented super critical, and this one is subcritical. So that is the okay. Now if I talk about this term, so what is this term? These are the specific depth. So specific depth, there is no such term that is specific depth. So next is the sequent depth. So what is sequent depth? So to this hydraulic jump, this is hydraulic jump, right? So let us assume two height, any two height. One is before this hydraulic jump and another is after this hydraulic jump. Say I take this point. Which one? Huh. Say I take this height and another height is this one. This is h1 and this is h2. So if h1 and h2, if these are two height having same space, having same specific force. Hello, am I audible? Hello. Sorry for this disconnection, but there is some internet issue. Okay. So what I am talking about this depth. So let us check. Say these are the two height, that is h1 and h2. One height is before this uh, your hydraulic jump. So what will happen if this h1 and if I take this any two height, said this height are different, this h1 h2 any height I take, if I found that at these two height having same specific force, So whatever may be the specific force at H1 and whatever may be the specific force at H2, if both these two are equal, then this is known as sequent depth, right? Next, another next term is alternate alternate depth. So in case of alternate depth, again if in these 2 points, say H1 and H2, if you found out that they are having same energy, in the previous sequent depth it is having same specific force, here same specific energy, right? So this is hydraulic depth. And next is the normal depth. If I talk about this normal depth, what is normal depth? So normal depth, basically if someone talks about this normal depth means uniform flow. That means no such certain condition. That means flow should be, there is no such hydraulic jump. So okay, so that is depth corresponds to uniform flow. So when there will be uniform flow? In the previous slide, previous one or two slide back, I have discussed about this thing. That means if gravitational force and frictional force should be equal, so that is normal depth. So these are the three depths. So in this question said specific force, so the correct answer is option B. So and another important thing, so critical depth. So critical depth means this point is talking about this critical depth. Let's see. That means the height where this critical depth. So it's a certain height where the specific energy is minimum. Specific energy is minimum for a given discharge or for a given flow. Okay. So the correct option is option B. Okay. I'm moving to this. I hope that you understand this thing. I'm moving to this next one. So this is the next question. Which of the following factor does not affect the drag force on an object? So just you can easily answer this from this formula of this drag force. If you remember, recall this formula of this drag force, you will easily answer this one. So I am giving you 1 minute time. Any idea? So I have already received one answer from the option C. Okay, let us check. So this drag force FD means what I know 1 by 2 CD, which is a drag coefficient rho into A into V square, right? So that is the formula. Yes or no? So what is CD here? CD is drag coefficient. Okay. So it depends on shape and flow. What types of flow? So next is density. Rho is A. Next is area. So these two factor doesn't depend on the density of fluid is there. So option A will not be the correct answer. D will not be the correct answer because shape of the object will that thing we have got. Next is the speed of the object and the temperature. Say so here this is the velocity, right, or the speed. So definitely it will affect the speed as velocity, so that will not be the answer. But no such terms is there where we from where we can say that the temperature of the fluid will affect. So that's why the temperature of the fluid is the correct answer, that it doesn't affect the drag force on an object. So option C is the correct answer. I hope that you understand this thing. Okay, I'm moving to this next question then. So the question is, a channel is said to be hydraulically efficient when option A, the perimeter is minimum for a given area, the area is maximum for a given perimeter, the perimeter is equal to the hydraulic depth. The last option is the channel is circular in shape. So I am giving you 1 minute. Use your fundamental concept and analyze this question. You will be easily able to answer this one. So please try to answer. So do not afraid to answer. Answer if it may be wrong. There is no such issue. Plus, please try to answer. Okay, so I am solving this. I hope that you don't have an idea. So about this question, so it's not an issue. I will be help you in solving this question. So basically, this what does this hydraulic efficiency mean? So the hydraulic efficiency means how efficiently a channel flow with minimum friction. So if the friction is less, the hydraulic efficiency will be more, right? So this depends on the friction. So that means if the friction is the main factor that depend that will convey information about this hydraulic efficiency, right? So for any given area A, say hydraulic radius R is A by P. So this will be maximum if the P will be, this is the formula, right? So from this formula I can say what I need hydraulic efficiency, that means R hydraulic radius, no, that means R should be high. So the perimeter is minimum for a given. So area, I consider area fixed, but the perimeter is less, so R will be more. So similarly, if the area is max for a given, so that can be another answer, right? Yes or no? So the third is perimeter is equal to the hydraulic depth. No, it will not be the answer. The channel is circular in shape. No, it cannot be the fully correct answer. So it should be among one A or B. So what do you feel? Which will be the answer? If the perimeter is minimum the for a given area, so that will be the answer. Okay. Say why I am saying this is that say for a given cross section area. So if the area is fixed, if I am talking about the option A, so that means there is smaller weighted perimeter. So friction basically occurs for this friction. It has less weighted perimeter, so the friction will be less and efficiency will be more for this. So option A will be the correct answer. Mainly because for a given cross-sectional area, the how much the perimeter, if the perimeter is less, that indicate the OIT perimeter is also less. So that also implies that less friction and more efficient in the channel, right? So this hydraulic diameter formula, using this formula and using the fundamental concept, we get the correct answer option A. So this is our next question. So this is a numerical, not fully numerical. It's a fully numerical question. Please try to answer this one. One more minute. Okay, I'm solving this one. So the lead formula for this lead force is FL equal to half rho V square A into CL. So given in this question rho, rho is 1.225. It is given kg per meter cube, right? Next is V. Velocity is given as 50 meter per second, and area A is given as 10 meter square. So now if you put, you will get the answer. So you just put all these things, you will get this answer as 18375 Newton, which is 18.375 kilonewton. So option A is the correct answer. You got me? Okay. Hmm. So sorry, there is a lot of network issue and losing is also going on. Now it's I think again. 1 second, sorry for this delay. Okay. So that is the here just we need to apply this formula, nothing else we need to do. So in this formula which is rho v square a into cl, use this formula and you will get the correct answer. Okay. So I'm moving to this next question. So what is this? The question is there. What is the most appropriate assumption for gradually varied flow in an open channel? So these are the four options, right? So, so I'm just giving you. So I'm just giving you this hint how to solve this one. So basically, this gradually varied flow for GF GVF, I represent this gradually varied flow as GVF. So it occurs when there is certain assumption. The first is that this flow depth changes slowly along the channel. Okay. Next is the velocity changes gradually. What is that means? That means the flow is nearly 1D. Next is acceleration is very small and vertical velocity component, there is no vertical velocity component. Okay, so which of this assumption is important here? The if I talk about this hydraulic pressure distribution, definitely, because here this we have studied about this thing along this z direction. The change in pressure with respect to the pressure gradient is directly proportional to this one. So definitely hydraulic pressure distribution should be the most, because already it's a gradually varied flow, so certain there is velocity changes is there, so pressure gradient should be there. So uniform velocity distribution, no, because already it says it's gradually varied flow. Next is no pressure variance along the flow direction. Already it is talking about varied flow, so there should be pressure difference. So the flow is always turbulent. There is nothing mentioned in this question about the information about this Reynolds number is given, so that will not also be the option. So option A will be the correct answer. Okay, so option A is the correct answer. So I am moving to this next question. So I am just giving you 1 minute time for this because actually I have discussed about this depth a few question back. So I hope that you will be easily able to answer this one. So Vidisha and Ridvi, please try to answer this one. Already we have lost a significant time in today's class because of this network and this load shedding issues, and I apologize for this. So which is answered option A. Hmm. So both of you are the same opinion. Yes, it's option A. So option A is the correct answer. Why? Because already I have discussed about this thing. The critical depth, it's the depth which is having the minimum specific energy, and this conjugate depth is also known as your uh, sequent depth. Okay. So which means that at 2 point, one is below this hydraulic jump and another above this hydraulic jump. If certain two heights having the same specific force, so option B will be option 4. B is corresponds to 4. A is corresponds to 2. And alternate depth means having the same specific energy. So the same specific energy option 1. The normal depth means uniform flow. We have studied about this thing. So option D will be the correct answer. Okay, good. Both of you have answered it correctly. So moving to this next question. So here the flow rate in a wide rectangular open channel is 2 meter cube per second per meter wide, right? So it is given. So the channel bed slope is this much. So this meaning roughness coefficient is also given. The slope of the channel is what? So you just need to check whether this depth and this critical depth, these two concept is required. Okay, just I'm giving you this formula because here this you need to recall this formula. So derivation is there. That is not the part required for you. So say so actually to check whether the slope of the channel is steep, critical, or like you have to check what is the what is called this normal depth. You have to find out this normal depth. So first find out this normal depth. Normal depth, if I represent this normal depth as yn, so which is n q by so root so to the power 3 by 5. Okay. And critical depth, this formula is q square by g to the power 1 by 3. So you find out these two value and check critical depth yc. Which one is greater? Either yn is greater or yc is greater. Okay. So please check this one. So see if both strip yn, say if you got this yn equal to yc, that means this is your critical, right? And also if say yn is less than yc, this means that means it will rise, it will be stiff. And if yn greater than yc, it will be mild. So please try to answer, find out this thing. Just I just forgot to mention about this thing. What is this? Which term represent what? Right? So basically, this term yn This in case of yn, this n is the meaning roughness coefficient, right? And this q means this flow rate per meter wide, which is also given. And so is the channel bed slope. Okay. Okay, please answer this one. मोबाइल से कनेक्ट। Again, sorry, this significant problem is because of this network issue. Today, I don't know what is happening here in IIT Bhubaneswar. So, and I have been connecting with my mobile internet. Still, this issue is there. So, anyone who solved this one, please let me know. Anyone? Riddhi, Vedisha, anyone? Yes. So, one I have received one answer from Riddhi. So, let us check whether this one is correct or not. So in this question, n is also given. N is given as 0.012 and SO is slope of this one is given as 0.02 and Q is 2 meter. If I put all these things here into the power, you will get value around 0.67 like that something. Okay. So that is yn. And similarly, if you put this value here, you will get a value something around 0.74 meter, right? So what that indicate? Which one is greater? Yc is greater. So I can write yn is less than yc. That means the depth is already you. If you remember this diagram in the previous diagram, certain like this way. So this is our critical depth as yn, this is a yn. So yn is less than yc. So in this region, so the flow is increasing to steep. So the slope of the channel is in steep. Okay. So the correct option is option D. Okay. So next question. So this so we have few more question for today's. So in a water discharge into a rectangular horizontal channel from a sluice gate and undergoes an hydraulic jump. So the channel is 25-meter wide and the flow depth and the velocity before the jump are 2 meter and 9 meter per second respectively. The flow depth after the jump is what? So that is the question. So as because of this network issue, we will not be able to continue this class anymore. So also we have a additional classes tomorrow on from 3 to 5. So I hope that you will join this and we will discuss about this summary and what are the topics that are important for your exam point of view and all these things we will discuss in the tomorrow's classes and this one will be the last question for today. Okay, the remaining we can explain tomorrow if you have any doubt regarding this. So I hope that so in this question 2 points certain points are given. Say this is 1 point, this is another point. So this is y2, say this is y1, right? So what is given? So the flow depth and the velocity before the jump. So it is given y1 is given as 2 meter and the velocity corresponding velocity v1 is given as 9 meter per second, right? So the flow depth after the jump. So here y2 you need to find out. So basically, as this is a rectangular channel and undergoes an hydraulic jump. So here in these two cases, what we need to do, we need to assume this sequent depth. What is sequent depth? The sequent depth means the two depth having the same specific force, right? So so considering all same specific force, one derivation that you will get, this is y2 by y1. This is 1 by, let me check this one. Hmm. Y2 by y1 is, this is the formula, 1 by 2 root over 1 plus 8 f1 square minus 1. So that is the formula where f is the Froude number. Okay. So the Froude number, what is the formula? The Froude means V by rho gy. So but in this question, what is given? V1 is given, right? And anything else? G you know, Y you know. Accordingly you can find out. So please find out this thing. So you need to find Y2. So I have given you all this formula. Please solve this one. Also say if V you know this fraud. Hmm. Another formula always please remember that this water discharge, this can also be find out by multiplying this velocity into y1 del. So you will get this discharge rate, right? So that is not required here, but just find this fraud number initially. So just calculate this one. This fraud number, this f1, this is given as 9 and G, if I consider it as 9.81 into, this is given as 2. So we will get value around 2.03 something. So if I put it here, 1 by 2 root over 1 plus 8 into 2.03 square minus 1. So that will be around 4.9 around something. So y2 is this one into y1, which is 4.83 meter. So the correct answer here is 4.83 meter. Okay. So I'm moving to the next question. Okay, and two more short questions. So I think that it will be better if we complete by today. So similar types of question. So please try to answer this one. So here the pre-jump fraud number, and before the jump the fraud number is given. F1 is given already. So the ratio of the second depth is what? So this is the option. Use the same formula and answer this one. Just calculate and tell me the answer. Which one will be the correct answer? Hmm. Yes, someone answer may have answered, I think. Yes. Yes, Vidisha, good. Option C is the correct answer. Very good. So similar types of question you can expect in the exam. So option C is the correct answer. Okay. So I will share all this thing with you after this class. And the last question for this today's session. So a rectangular open channel is there. Its width is given as 5 meter and it carries a flow at a discharge of 25 meter cube per second. That is Q is given. The flow depth is 2 meter. Calculate the fraud number. So just you need to remember this fraud number FR or F, whatever you represent, B by 2 GOI. So you have got Q. Q is 25 meter cube per second. So from Q you can calculate V, right? So calculate V. How? Velocity is Q by, say unit is meter cube per second and velocity is meter per second. That means here you need to divide it by area. From the unit analysis you can also say for area it's an open channel, for its width is given, depth is given. So you can find out this velocity, and as the depth is given, so y is already known to you. So put this value and find the fraud number and tell me what will be the answer. So this is a simple question. So both of you have answered option B. Yes, both of you are correct. So that means here you will get this is 25 and the area is 5 into 2. So 10, that means 2.5, right? And this fraud number you will get as 25 by root 9.8 into 9.8 into 2, which is your result, and you will get it 0.56. Uh, this, so the correct answer is option B. Okay. So up to this for today's session. Any more confusion? I hope that you understand this concept of this open channel, and I also apologize for this delay. At least 10 to 15 minutes have been wasted because of this network connectivity and this load shedding issue. So that is very rare and it's an unfortunate. We can't do anything. And hope that you enjoy today's session, and I will upload all these things, and a link will be shared with you from this NPTEL site. Onward, and also on this also I think the link is with you, right? You can find this thing here, the uploaded videos, previous video. If you wish, you can check. If you have any queries, come up with these queries in tomorrow's class. Tomorrow will be our last session for this semester, where we will discuss about this discuss about your problem. Any problem you can share with me, and also about regarding this problem, and also I will discuss about some important for your exam point of view. So please go through this concept today, and that will help you to clarify this thing for tomorrow's classes. I hope that you do not I consider that you do not have any confusion, right? So can I wind up today's class? So thank you everyone for joining. Yes, thank you. Have a good day. Okay. So and bye everyone.